Alright, so here's the homework assignment for lesson number 5. The first question asks us to sketch a graph of the function h of x. So if we go through and make a quick sketch, remember, sketch doesn't have to be perfect. So if we have the graph of log of x, log base 4 of x, we know that there's no horizontal translation or any kind of vertical translation. So I know the graph is going to look just like the ones that we did in class today. Some of the key features that are on this function, I know it's going to have a x-intercept at 1. I know the domain is going to be all of the x values from 0 to infinity. I know the range are going to be all of the values from negative infinity to positive infinity. And I also know that it's going to have an asymptote line of x equals 0. There are other things about this curve that we could talk about, but those would be the key things I'd want you to be able to describe for me. Number 2 says, the graph of y equals log base b of x is shown below. Determine the value of b and explain your reasoning. So to determine the value of b, you need to choose a point that's actually on your curve, but you don't want to choose the point 1, 0, because 1, 0 is on lots of different curves. So I'm actually going to choose this point here, 7, 1. So if the x value is 7 and the y value is 1, I can replace those in my equation and solve for b. So I have 1 equals log base b of 7. Now I could guess and check at what b is going to be, or I can rewrite this as an exponential function. So I know if it's an exponential function, the base is b, the exponent is 1, and the answer is 7. We learned that in lesson 3. Therefore, b is just 7. Number 3 says, explain why y equals log base b of x does not have a y-intercept. The reason why this does not have a y-intercept is because b to the y equals x. A y-intercept is going to have an x value of 0. So b to the y equals 0. There is no value for y that makes this true. The next one, number 4, it says explain why the x-intercept of all functions in this form is x equals 1. So in this form, if I was to rewrite this as an exponent, it would be b to the y equals x. Well, if we're talking about an x-intercept now, we're talking about y equals 0, b to the 0 equals x. Well, b to the 0 equals 1 because any value to the 0 power is 1. Therefore, x has to equal 1 no matter what value b is. So if you were to graph log base 10 of x, or log base 2 of x, or log base 1/2 of x, all three of those functions would look slightly different, but they'd all have the same x-intercept. Number 5 says to find the x-intercept. So as soon as we see x-intercept, we know y is 0. I don't know what that was. Log base 2 of x minus 3. So if I rewrite this as an exponent, it would be 2 to the 0 equals x minus 3. If you haven't noticed in the last few examples, being able to change from a logarithm to an exponent is a very key, important feature. So this becomes 1 equals x minus 3, and then I could add 3 to both sides and get x equals 4. I also could graph this and see that it would intersect the x-axis at 4. So if you were to graph that function, it would look something like this. And it would have an x-intercept at 4. It doesn't say algebraically, so I'm showing you how to do it. Number 6 says to find the inverse of y equals ln of x. As soon as I see ln, I know that that's a log with a base of e. So if I rewrite that as an exponent, it becomes e to the y equals x. Now I want to find the inverse, so that tells me to switch the x and the y. y solved for. So we're done.
This is my homework.
Hopefully this video helped.